Select the major product or products of the following reaction. So if we take a look at this reaction, our starting material is an alcohol, and that alpha carbon of the alcohol has bonds to 1, 2, 3 other carbon atoms. So this is a tertiary alcohol. And what we see we are reacting it with is a strong acid, that's sulfuric acid, and we're heating it up. So a tertiary alcohol, if you treat it with a strong acid and you heat it up, this reaction is going to be an E1 elimination reaction. So to find the product of this, let's draw the mechanism. So here is that tertiary alcohol. So there's the tertiary alcohol. And so alcohols, the oxygen has 2 lone pairs of electrons, so they can act as a nucleophile or as a base. Since we are reacting this with a strong acid, we expect that this is going to react as a base. So here is the structure of that sulfuric acid. And so what we expect to see is that the alcohol, being a base, will react with one of these 2 acidic protons. And what this will do is it'll transform the alcohol from a bad leaving group. It's too strong of a base, hydroxide ion, to be a good leaving group. But by protonating it, we've transformed it from a bad leaving group to a good leaving group, because now if this leaves, it'll leave as a neutral water molecule. And we said this reaction is going to be E1, so that's a stepwise elimination. So the first step in either an E1 or an SN1 is that your leaving group is going to leave. And so the leaving group leaves. And what that does is that forms a carbocation. And it's a tertiary carbocation, so relatively stable. It's not going to rearrange in any way. And then the second step would be the step where we pull off a beta hydrogen. So we have beta hydrogens here, here, and here. For an E1 reaction, you don't have any constraints in terms of where those hydrogens need to be. So what will happen is whatever base you have around will simply pull off the hydrogen that will give you the most stable alkene. So that would be the interior alkene here. So we have 2 hydrogens. We have a water molecule that we just liberated. We can go ahead and use that water molecule as the base. And we can show it removing one of these 2 hydrogens, and these electrons coming in to form the more substituted and more stable alkene, which is C.